Okay, hello guys, and welcome back to day 2 of Trig. This video will be a lot shorter than the last one. A bit of an apology for the last long video, but it was all very important information. Alright, now day 2, we are talking now, as promised, about solving for angles. So last time we were here, we solved for the side lengths. Now we're going to solve for the angles. Okay, if you have your notes packet, you can flip back to the calculator page. If not, that's okay. But you may or may not remember that we had 3 functions at the end of the calculator page that talked about the inverse functions. Okay, I'm going to erase this. So the trig inverse functions, or the inverse trig ratios, use the exact same ratio pattern as the last one. And what I mean by that is that SOHCAHTOA still applies here. Okay, that has not gone away the slightest. We're still going to use it. But now we have things like the inverse of sine, the inverse of cosine, and the inverse of tangent. Now, if you're using any of the calculators we mentioned last time, this is how you'll see it. But occasionally, if you have an older model calculator, or if you, for some reason that I'm not aware of and don't understand, use the internet, despite having 3 calculators available to you, you might see it as arc sine, arc cosine, and arc tangent. And of course, theta is here at the end. Now, these are all completely valid. All of these, whether you use inverse or arc, they all mean the exact same thing. So don't let that trip you up. Now, when we are finding the angle measures, we're going to use the side lengths given to us to determine which one to use. And then we're going to use the inverse function of the calculators. Now, before we get started, I do have a small edit to make on our worksheet. And that is to change the problem a little bit. So I'm going to get rid of the x's and add in my own numbers. Now, the problem, the worksheet should have done this already. It didn't, so now I'm editing it in video. You can edit it on your paper. All right, so again, we're going to use the side lengths that were given to figure out which ratio we should use. So I'm going to do theta first, because I like theta better. If you want to do alpha first, go for it. We'll get the same answer regardless. I'm going to do theta first. And now theta, this is the opposite side and the adjacent side, which is tangent. So I'm going to use tangent, which is the tangent of theta is equal to 6 over 20. Go ahead and reduce your ratios. Tangent of theta is equal to 3 over 10. Now, I'm going to make a step, and it's one big step, so keep up. Last PowerPoint, I mentioned that none of the operations can separate tangent from theta. Addition, subtraction, multiplication, division didn't work. If you divided tangent, you were dividing tangent of theta. But I also said that there's one small exception, and that's the inverse functions. The inverse functions separate the theta, the angle, from the trig. So, I'm going to write right here that theta is equal to the inverse of tangent of my fraction. And that's what the inverse does, is it separates the trig function from the angle and puts the side ratio in the parentheses instead. Okay, I've kind of dropped my parentheses, but there they are in case you were wondering. Now this is our calculator ready version. Okay, this can be plugged into the calculator. And this is what I'm going to plug into my calculator. So I plug it in, and I get that theta is equal to, change colors, 16.69. And you can round to the hundredth spot. If you round to 16.7, that's fine. I'm just going to stay at the hundredths for my consistency. All right, now if you did alpha, I'll just do alpha real fast. tangent of alpha is equal to 10 over 3. I'm going to make use of my patterns, which means that alpha is equal to the inverse tangent of 10 over 3. I'm going to plug that in my calculator, and I get that alpha is equal to 37.3. Sorry, 73.3. And if you add those up and add up 90, you get that your angle is the same. Okay. All right, you guys go ahead and try the next one. The edits for this one is that this is 15, this is 3, so you're not solving for x. All right, so the video is going to pause. Go ahead and try to set these up. Get to calculator ready. When the video plays again, you'll see calculator ready for both theta and alpha, and then it'll pause again. When it plays, you'll see the answer. Good luck. And here's the calculator ready version for both theta and alpha. Notice how the ratio is the same, but the function is different. Let's see how that affects our answer. And there are the answers. Again, if you were to add up all your angles, you would get 180 degrees. That's always a good thing just to kind of spot check and make sure, because it's a very simple and easy check. And that way you don't make any simple and easy errors. Last one, the edits for this one, we're solving for x this time. This is 9, this is 5, and you are going to solve the triangle. Now, the instruction of solving the triangle is a phrase that means you are going to solve for every single missing piece, which in this case means 2 angles and a side. Now, I can hear you saying through the camera, we can use Pythagorean theorem to solve for x. I realize that. We're not going to. We're going to use trig to solve for x. And in your homework, I want you to also use trig to solve for the third side. Just get in the practice. Now, as we move past this particular section, there's going to be a lot of different ways we can find that third side. Pick your method based on what you're given. But for right now, I want you practicing trig. So, in a problem like this, the first thing we're going to have to do is solve for our missing angles. We can't use trig to solve for the side if we don't have an angle. So, we get to solve for the angles first. So, I'll mix things up this time. I'll solve for alpha first. Show it some love. All right, so alpha, I have the opposite and the adjacent, which is tangent. So the tangent of alpha is equal to 5 over 9. There's no simplifying that, so I'm just going to go straight into my trig function. Alpha is the inverse tangent of 5 over 9, which means I have that alpha is 29.0546. Now, there's a reason I left it to the 4th decimal place. There is a method to my madness. Go ahead and do do theta, and leave theta in the 4th decimal place also. All right. Now, last lesson, I talked about how when you're working, leave the decimal to the 4th place. But when you're writing your answer down and turn it in, you can go ahead and round. What that means is that the more decimal places we have, the more accurate our answer is. In fact, sometimes changing your decimal will even change the complete whole number. You'll get a different number if your decimal is wrong. Okay? Think about if you've ever hung a picture. You've ever hung a picture by a nail or hung a banner by a nail. If the whole picture isn't exactly centered on that nail, well, when you back up, it's really obvious that the picture is tilted. So the decimals matter. And the way they matter is when we use them in the next step of our problem, and that's solving for x. We still have to solve for x. Now, I'm going to use theta to solve for x. I've given alpha enough love. I'm going to use theta. You can use alpha if you want. We should get the same answer, so that'd actually be neat. You use alpha, I'll use theta. If this works, we get the exact same answer. And when I do my problem, I'm going to keep theta to the 4th decimal place. Now, I've written it to the 100th place over here, but I'm ignoring that for now. I'm going to use to the 4th decimal place. So I'm solving for x, and I'm going to use cosine because I feel like cosine is unloved. So we'll go with the cosine of the whole number, 60.9453, is equal to, we're using cosine, so that's going to be 5 over x. Hopefully this is familiar to you now, so I'm going to get this expression into calculator-ready form. And there we have the calculator-ready form of this problem. Yes, it's a lot of writing. There are different ways you can use to shorthand as you're just doing the problem, but the calculator-ready form needs to have all 4 decimals. And then when you put it into the calculator, you should get for your final answer of 10.29. If you used alpha, how did you do? Did you get the exact same answer as me? We'll compare answers when I see you next in class. Good luck on your homework.